So in this video, let's look at two more example problems where we're looking at the domain of sequences. So Raimundo is writing an explicit function for the arithmetic sequence 20, 15, 10, and so on. Notice that common difference that we are subtracting 5 from one term to the next. And he comes up with the formula S of n is 20 minus 5n. So what domain should he use for S so it generates the sequence? And with this formula, we need the first term to be 20. And in our formula here, we have 20 minus 5n. So basically, to start this off, we need this term to be equal to 0. And to get that, we would have to start with n is equal to 0. So n equals 0 should give us our first term. Whereas if we want our second term, we would want n equal to 1, since then we'd have 20 minus 5. So let me write that out. So if n equals 0, S of n, or S of 0 in this case, would be 20 minus 5 times 0, which is just 20. And if we want our second term, we set n equal to 1, so that's S of 1 is 20 minus 5 times 1, or just 20 minus 5, which is 15. And so on. So n equals 2, we'd subtract 5 twice and get 10. N equals 3, we subtract it 3 times, and we get 5. So it has to start at 0, then go to 1, and it needs to be a whole number. So it has to be an integer. If it's a decimal number or any number, this wouldn't make sense. So going to our answer choices, we know it can't be 1, and so it's down between these two. It has to start at 0 and then increase from there, but it needs to be an integer. It cannot be any real number since we're not including decimals here. So that doesn't make sense, so that leaves us with choice A. And let's do one more problem. And in this one, we have Margaret writing a recursive function for the geometric series, or sequence. And it starts at 10, then goes to 30, 90, and so on. Notice the common ratio, the number we multiply by to go from one term to the next. We are always multiplying by 3 to go from one to the next. And she comes up with that t of 0 is 10. So when n equals 0, you get 10, and 10 is our starting value. So it looks like we're starting with 0 and then counting up with integers here, since for these sequences we always use integers. But we also have this pattern, so let's just double check. So for n equals 1, let's plug that in. We get t of 1 is equal to t of 1 minus 1, which is t of 0. That starting term multiplied by 3. So this becomes 10 times 3, which is 30. And that is our second term there. And we could do one more if we want. We could do t of 2. Since the pattern says for the nth term, we take the term before that and multiply by 3. So to find the second term, we look at t of 1 and multiply that by 3. And t of 1 was 30. And 30 times 3 gives us 90, which you can see that is the third term in this sequence. So the domain of this sequence, it starts at 0 and then it counts up as an integer. So that looks to be choice A here, where n is bigger than or equal to 0. It starts at 0, and n is an integer. It cannot be any number. That's why choice B is wrong, and you can see that C and D are both wrong because they start at the wrong number. If we started at 1, you would not get this first term at 10. In fact, the first term would be 30 in that case.